to see domain and range of this one, there's a couple different ways you can do this. So continuing, there's a couple different ways you can go about finding the domain and range. It never hurts to graph and then look. So that's what I'm going to do. So I know that a square root function, the shifting works the same for all functions. So underneath, added with x is our shift left and right. We always go the opposite. So we'd be going back 3 and down 2. And then we know our square root functions look like this, right? Something like this. We only need a rough sketch for domain and range. So the domain is x values. Now I'm seeing this and I mean, it's fine for right now. So our domain is left and right. So you've got to really look with your eyeballs and say, what's my lowest x value? Where does it start? The lowest x value. -3. Did it start right at -3? And it's a closed circle, meaning it includes it, so it's a bracket, and it grew on the x-axis to positive infinity. All right, so that's our domain, and then our range is y values. So now you have to shift your eyeballs. How far down to up? The smallest y value. Where does it start on the y-axis? -2, and it grows to positive infinity. Now, what if I were to change this and say, write this as an inequality? You've got to be able to do that. So let's practice that right here and now. So if we were writing this as an inequality, our domain is x values, right? It started at -3 and grew to positive infinity. So when we say our x values are greater than or equal to -3, does that make sense on how to write it as an inequality? Now let's do y values. Range is y values. They started at -2 and grew to positive infinity. So our y values are greater than or equal to -2. So you really have to be able to do both. And what I've seen on the end of level test is more of this. They say write it as an inequality. So you've got to be able to adjust your thinking and write it as such. Is everybody good with that? No, but we're just going over it for the first time. Any questions on how to do that? Okay. In the future, I might say write it as an inequality. Okay, so let's get to what we're learning today. So first of all, I just need to say, first of all, we're doing 5-7, solving systems of equations, and now we're going to have 3 variables today. So we're going to be solving systems of equations with 3 variables. So recall, this is when we were solving systems with 2 variables a couple days ago, and that was pretty easy, right? We used a few different methods. Any method will work. Your method of choice on the test, you can do whatever you want. I don't care. As long as you get the right answer for x and y, we're good. So solving systems with 2 variables, we did substitution, elimination, and grafting, and you can choose. So we found the xy point. So, oops. Well, I'll just give myself something to write in here. So we found the xy point where these 2 lines intersected, right? And that was our answer with an equal sign. Okay, so today we're going to have, instead of just x and y, we're going to have an x, y, z. So it's going to become 3 variables. So before we actually get into it, just a couple of things so that you guys understand what's going on. This is actually really cool stuff. So we know that the map that we usually work in is just like this, right? It's an x, y grid. So this is called like flat math. So we do math in flat surfaces at this level. So do you guys understand x, y is flat? It's not 3-dimensional, right? So now understand something cool. This might be for the first time you're realizing this. X, y, we look at it up like this, but really technically it's laying down. So if we were to look on the floor, we're dealing with flat math. So this is our x-axis. This is our y-axis. Does everybody see it? X, y. Well, when we get into 3 variables, you guys, there becomes a z-axis. So the up and down part of our world is the z-axis. So instead of having an x and a y like this, we have something that looks more like this. X, Y, Z. Now you don't need to write this down. I'm just kind of helping you see. Now do you see how that looks like a corner of a room? That's where 3-dimensional space comes in, is when we have a z-axis. So once again, literally, this is our z-axis, up and down. Do you all see it? It's kind of cool. So this is x, this is y, and then all of a sudden there's z. So then that's when we can see things in 3-dimensional space. So do you see how that looks 3-dimensional? It looks like the corner of a room. So So you don't really get too in-depth in with this. You do in Calculus 3, you get way in-depth with three-dimensional math, but we're just dealing with two-dimensional math, except for today. We are dealing with three-dimensional math, but we're not getting in-depth with that. I just wanted to kind of get you guys thinking about that, and it's pretty cool stuff. So what we're doing today is we're going to be we're going to be dealing with lines, we're going to be dealing with planes, and we're going to look for, and since we have three variables, there'll be three different planes. And we're going to be looking for their intersection points. So understand there's going to be some times where there's no solution. So we're going to look for where all three planes intersect. So this is no solution because the planes intersect here, but that third one doesn't intersect with those two. Does everybody see that? These two planes intersect right here, but they don't all three intersect somewhere. So this would be considered no solution. Does that make sense, everybody? Okay, so we're just kind of getting we're going to do it algebraically, but I'm giving you an idea of why this math is what it is. So do you see right here how this line, this plane, and this plane never intersect? So we need all three of them to intersect at one point. So that would also be no solution. And then right here we have these three parallel lines, or three parallel planes, so that would be no solution as well. Now here's when we get one solution, one exact solution. So, do you see how all three planes exactly intersect at one spot? So this is when we'll get an x, y, z as an answer. So x, y, z. And then this is one solution, one specific solution. And then right here, do you see how these planes all intersect? And basically, couldn't we smush those planes all together and it's just one big plane? So that would be infinite number of solutions. So, anyways. Just so you know where the solutions are coming from. We're not going to do it graphically. We're going to do it algebraically. So that brings us to problem number 5 on the worksheet. So this is systems of three equations. We have, on number 5, we have 2x minus y plus z is equal to negative 4. This is a plane. I have 3x plus y minus 2z is equal to 0. That's also a plane. And then we have 3x minus y is equal to negative 4. We have three variables, thus we have three equations. Because we have three variables, we have three equations here. Now solving these it's not hard math, it just takes a lot of work. So don't be like, oh, it's not gonna be hard, it just takes a lot of work. So it's kind of fun though, you just gotta be really particular and careful. So first of all, take my suggestion. The first thing I do is say, okay, I'm going to eliminate a variable in the beginning. You can randomly choose whatever variable you want to eliminate, and you're going to eliminate it in every equation so that you're only dealing with two variables for a second. So right now we're doing it by elimination. So once again, I'm going to choose to eliminate either x, y, or z. Now I'm going to randomly choose to eliminate z. I'm randomly choosing to eliminate z. So now I'm going to go off to the side here, and I'm going to just I like to do bullet points and stuff so I can keep my stuff organized. So I'm going to take these two top equations and write them down here. So 2x minus y plus z is equal to negative 4, and then my 3x plus y minus 2z is equal to 0. I'm going to take those two equations and I'm going to eliminate z. Get rid of it. So we know how to eliminate z. The z's need to cancel out, right? So don't they just need to be exact opposites of each other? Yes.
Would it be easier to take out y?
Yeah, sure. If you want to go for y, that's fine. I was seeing something different, but there's 20 million different ways we can solve this. So how many of you would rather eliminate y? Okay, then I'll do that. That's fine. So starting over. So every problem you can all attempt differently. So you guys are saying, okay, the y's will be easy to eliminate. And you're right, they would. So I'm going to take the top equation, 2x minus y plus z is equal to negative 4. And my middle equation, 3x plus y minus 2z is equal to 0. So then I'm going to go ahead and eliminate y. That's fine with me. Let's do that. So let's add straight down. So because the y's are exact opposites of each other already. Does that make sense of why we're choosing y? Why you guys chose y? Okay. So 2x plus 3x. 5x, negative y plus y. So plus 0, and then 1z minus 2z. So minus z, right? Don't mess up your sign. If you make a sign up here, you'll go through a 15-minute problem and get it wrong. Okay. And that's equal to negative 4 plus 0. Negative 4. So we have 5x minus z is equal to negative 4. Now I'm going to leave that alone for a second. I'm just going to highlight it so I don't lose my focus in a minute. And I'm going to do the same thing right here with these two equations, because won't the y's cancel out if I choose these two? So I'm doing another bullet point, and I'm going to use the middle equation, 3x plus y minus 2z is equal to 0, and my bottom equation, 3x minus y, and then we don't have a z, is equal to negative 4. And now we'll add those straight down because the y's will cancel out. Great, that's great. Good idea. So 3x plus 3x is 6x. Y minus y is 0. I'm not going to write it in there. Don't we have negative 2z plus no other z's? Yeah. So we still have minus 2z's. And that's equal to negative 4. So now we have these two highlighted equations with x and z's only, right? So I'm going to go off now and I'm going to do just to keep my work nice and pretty, a little star. So I'm going to use those two equations, 5x minus z is equal to negative 4, and 6x minus 2z is equal to negative 4 to solve for x and z. And now it's just like we did the other day, right? Just two variables, so we can solve by, it says elimination. So I'm going to get rid of z. So are we good up to here? I need to slow down. Okay, are we all good? So now I'm going to use elimination to get rid of x or z. The z's are going to be pretty easy to get rid of. I'm going to do, if I multiply this by negative 2, that'll make that positive 2z's, right? We need it to be exact opposites of each other. So I'm going to multiply by negative 2. So I'm going to write this down here if you don't mind, so just keeping your eyes good here. So we're going to have negative 10x plus 2z's is equal to negative 8. And now we don't have to deal with that top equation anymore. Positive 8. Thanks. Good fix before it was too late. Good point. We all good up to here. So I just crossed out the top one so I can keep my eyes focused here. So then I can add straight down. 6x minus 10x is negative 4x's. Negative 2z's plus 2z's is gone. And that's equal to negative 4 plus 8. Positive 4. Now we can solve for x. So we'll divide both sides by negative 4. We get x is equal to negative 1. We just found x. Yay! So now I'm going to go ahead and plug that back into one of my equations to solve for z. Because we can go back right here and plug in that x value we just found and solve for z. So I'm randomly choosing this one because I only have x and z to go with. Does everybody understand how if I plug in x, then we can find z? So I'm going to plug that in. So we have 6 times negative 1 minus 2z is equal to negative 4. So I'm going to have negative 6 minus 2z is equal to negative 4. So I'm going to add 6 to both sides. So I have negative 2z is equal to 2. Then we'll divide both sides by negative 2. And we get z is equal to negative 1. We have x and z. Yay. Only one more variable to solve. And the last variable is the easiest. Yes. Okay. Are you sure?
Yeah.
Okay. So we have x and z, right? Negative 1, negative 1. So I'm going to scroll up. Now look, wasn't our original equations have x, y, and z? So now that we know x and z, can't we just plug it in and solve for y? So the last one's always the easiest. So I'm going to just section me off here so I can keep my work nice and pretty. So I'm just randomly choosing to plug it into the top one. So we have 2 times x. X is negative 1. So I'm going to write that up here so we don't forget. X is negative 1, z is negative 1. So we have 2 times negative 1 minus y plus negative 1. Z is negative 1. That's equal to negative 4. Do you have questions back there? So then let's go ahead and solve. So we have negative 2 minus y minus 1 is equal to negative 4. Am I going too fast? So, negative 2 plus negative 1 is negative 3 minus y is equal to negative 4. So I'm going to add 3. So we have negative y is equal to negative 1. Divide both sides by negative 1. So y is equal to 1. And we write our answers as x comma y comma z. So the answer is negative 1 comma 1 comma negative 1. And there's the solution. That's where these planes all intersect. It's a lot of work, but I'm only assigning you around 5 problems, if that. Okay?
So, which ones do you...
So don't fret. Yes.
Which ones do you plug in to get y again?
Well, you just solve for x and z, but then you might solve for something different, right? You might solve for what? But, so you have x and z, so then you plug it into x and z,
So any equation.
solve for y. In any equation. Good questions. Do we need to do one more, maybe? You're sure? You're sure?
Yes.
Okay.
We are precision.
I'll let you try it, and if I need to bring you back to me, I will. So, these are the problems I want you to try. Now, understand, the first person to get them all 100% correct gets a candy bar. But I'm not going to give a whole group a candy bar. So, I mean, you can work in a group, I guess, but if your group gets it, then I'm not giving their whole group a candy bar. The first person to get them all right will get a candy bar. Alright, so I'm going to do number 13. Now maybe you don't like elimination, substitution might fit you better. So let's go through this. So first of all, I'm going to choose an equation and I'm going to solve for a x, y, or a z, whichever is the easiest, and won't give me fractions. So I'm randomly saying, well, look at the top thing here. Can I solve for any of those variables pretty easily? Yeah? So there's 20 million ways to do this. So I'm trying to look at this and figure out what's the best. You say do the y first? Let's do y first. I like that. So let's solve for y. So I'm going to use the top equation, x plus y plus z is equal to 0, and I'm going to solve for y. So I've got to get y alone. So I'm going to subtract x from both sides, and I'm going to subtract z from both sides. Is anybody too hurt or too confused if I do it at the same time?
What?
Oh dear.
I got it.
I'm just doing it in one step, but I'll do it piece by piece if I must. That's one. We have y plus z is equal to negative x. Now I'm going to subtract z from both sides, right?
Okay.
So I have y is equal to negative x minus z. Is everybody comfortable so far? Well, now I'm going to go ahead and take that and substitute it into the other equation, either or, but we're not going to substitute it in here, right? There's not a y.
Yeah.
But if I substitute that into the other equation, right here for y, so I'm going to point to where I'm substituting it in, won't it give us an x and z equation only? Okay, now let's plug in our y. So we're substituting in y for wherever there's a y. So we're going to have, I'm using this equation, 3x minus, I'm substituting in y. Anytime we make a substitution, I put it in parentheses. So instead of y, we're rewriting it as this. So it'll be negative x minus z. Is everybody comfortable that I just substituted it in right there?
Yep.
Then we still have plus z is equal to 4. Do you see?
Wait, where do you put it?
I substituted it in for y. So now I'm going to simplify it. So we have this negative is going to distribute 3, right? Distribute through, right? So we're going to have plus x and we're going to have plus z. Am I true? So we have 3x plus x plus z, and then don't forget about this plus z equals 4. So I have 4x plus 2z is equal to 4. Now I'm going to highlight that. Now look right here. Don't we just have an x and a z equation? Can I put those two next to each other and solve for x and z? So I'm going to do that. So I'm going to bring those together, and I'm going to say, okay, so 5x plus z is equal to 7. And once again, a lot of you are like not doing your work. and then you're messing up on sign errors, and put them next to each other because slow and steady wins the race for these. Not making one little sign error. So now I'm going to eliminate Z. So this is just like everything we've been doing the past few days, the easy stuff. Solve for Z, I'm going to use elimination. You can use either or. Elimination or substitution at this point. So I'm going to go ahead and multiply this top thing by -2 to get my Z's to go away. So I'm going to have negative 10x minus 2Z is equal to negative 14. I'm going to cross out the top because I don't want to focus on that anymore. And add straight down. Negative 10x plus 4x. Negative 6x, that's 0, so that's good. And we get is equal to negative 10. So this is going to be fractions. Which problem is this? Let me check. 13. No, I didn't get fractions in my answer.
Well,
Where did I make my sign error? Where did I make my
At
error?
the very beginning, because it's not on the paper, it's not plus C, it's minus.
That's where. See if you write down anything wrong. Oh, that's where.
I was so confused for some.
Wow.
So on the paper it was minus C, so this should have been,
Oh my gosh.
oh yeah, yikes.
No.
I thought there was a minus for a second, then we realized it so far.
Plus C, hey, let's all not cry too much. Go home for mommy. But let's all just fix it. Okay, so look, I just need to make that a plus C, right? That's a quick fix.
How did you mess up?
When I was writing down the original problem, because I'm human too, I know that you guys think I'm perfect. And I'm close. So now what we have is 3x. So I just changed this to plus C.
Yeah, right.
So 3x, still plus x, and then now it's minus z plus z is equal to 4. So we have 4x, the z's cancel out, is equal to 4. There we go! Hallelujah! Because now, isn't it easy to solve for x?
Half an X. Yep.
So divide by 4, x is equal to 1. Now isn't it easy to solve for z?
Yep.
I'm going to plug it back into one of my equations up here where there's only a y, or an x and a z.
Just do.
So I'm going to solve for y now by plugging it in.
Yeah.
So I'm going to plug it in right here. Do you see y? So we have y is equal to negative x. So y is equal to negative 1 plus... No, that didn't help us.
What, this blank?
What am I missing here?
I don't know.
Oh yeah, we don't want to plug it in with the y and z. Right here.
Yeah.
Let's plug it in right here. So we have 5 times 1 plus z is equal to 7. So we have 5 plus z is equal to 7. Subtract 5, subtract 5. Z is equal to 2. So we found x so far. 1. We found z so far is 2. And now finding y is easy. Right?
Right.
Plug it in. So I'm going to plug it in up here. So our x is 1 plus y, don't know why, plus 2 is equal to 0. No. I wrote the freaking problem down wrong, remember?
Oh yeah.
Sorry, I was like, why am I struggling so much? Okay, so really we have 1 plus y minus 2. So don't we have 1 plus y is equal to 0? Negative 1 plus y is equal to 0, right? Sorry, I'm just plugging it in up here. So we have 1 plus negative 2, right?
Yeah.
Which is negative 1.
Yeah.
So negative 1 plus y is equal to 0. So we'd add 1, y is equal to 1. So our answer is 1, comma 1, comma 2. So if you like substitution better, go for it. I don't care how you do it. So do it however you want.
Can we do another one?
So competition begins now with these problems.
Give me an example.
Another one. We got stuff on that last one, so.
No, you
Let's
don't.
see if we have time.
Take that back.
Ooh, well, the problem is, I think,
No, we don't need one.
well, I mean, some people might. Here's the thing, guys. If you want to solve using elimination, I don't care. Whoever gets these next 2 problems 100% right gets the candy bar.
Lot, not, yeah.
Sorry, sorry.